Okay, so let's continue our discussion of limits, and we're going to continue looking at these graphically. So we're going to calculate some different limits using a graph. Now again, from the previous video, we know that this right here is the limit as x approaches -3 from the right. This is the limit as x approaches -3 from the left. This is the limit as x approaches -3. And then this is just f of -3. So this is just what is the function at -3. That's all that's asking. Now, I briefly mentioned last time that for this top one, for the limit to exist, the limit, this limit, and this limit, the limit from the right and the limit from the left, have to be the same. So if these two aren't the same, then this does not exist. And we're going to do some examples here where this exists, and we're also going to do some where this does not exist, and show you the difference between the two. One other thing that I do want to point out in this video is that this value down here, the value of the function, this does not have to be the same as the value of the limit of that function. And again, we'll do some examples where they are the same, and we'll also do some where they're not the same, so you can see the difference there. But just keep that in mind, that these two things are not related, or they can be related, but they don't have to be the same. And I'll show you some examples where they're not. But let's go ahead and start, and we're going to start this with -3. So let's calculate this one first. So what is the limit of this function right here as x approaches -3 from the right? So to calculate this, you're going to start on the right side of your graph, and you're just going to move from the right to the left. Again, we come down here to this dot, go back over here. Okay, we're still moving. Okay, now, ooh, look at that, we've approached -3. So -3, we're right there. And it looks like the y value right there is 0. So that means that the limit as x approaches -3 from the right, this is equal to 0. So now let's do the limit as x approaches -3 from the left. So we're going to start on the left side of the graph, and we're just going to move until we get to x equals -3. We're moving, okay, now we're there, and we're at the exact same place. So we're at y equals 0, which means that this right here is also equal to 0. So these two things are the same. So as you move from the right, you go to 0, and as you move from the left, you go to 0. So that means that the limit as x approaches -3, this right here, is also equal to 0. And now let's calculate the value of the function. So what does the function equal at x equals -3? Well, looks like the function is also equal to 0. So this is also 0. So in this example, the limit from the right is 0, the limit from the left is 0. Since those two values are the same, the limit is equal to 0, and the function at x equals -3 is also equal to 0. So in this case, all of these are equal to 0. The function and the limit are the same, the limit exists, and the limit equals 0. So now let's do a different example. We're going to change all of these. And this time let's do x equals -1. So we're just going to change all the -3s to -1. So we're going to see what happens now. So let's go back and let's get the red marker, and let's do it all over again. So let's keep starting with this one. So let's start with x equals -1 from the right. So again, you're going to start on the right side of the graph until you get to -1. So you get here, we jump down, come back, and we're moving. Okay, now you see now this entire line right here is -1. So right here we've reached x equals -1. And what is our y value? Our y value here is 1. So that means that the limit as x equals -1 from the right is equal to 1. Now let's do the exact same thing, but let's do it from the left. So if you start over here and you move, we're moving, and we get right here. Okay, now we're at x equals -1, but where are we at? We're at y equals 0. So this is actually equal to 0. Oh, ugly. There we go. So here's an example where if you come from the right, you go to 1. If you come from the left, you go to 0. These two things are obviously not the same. 1 and 0 are not equal. And so because these two aren't equal, the limit as x approaches 1 does not exist. And if it does not exist, people typically just write dn, I apologize for the ugly drawing, but dne. People write dne just does not exist. So in this case, the limit from the right and the limit from the left are not the same, so the limit does not exist. Now what happens to the function? What is f of negative 1? Well, if you look at f of negative 1, where's the function defined? The function is defined right here. So this would actually be equal to 1. So that's all you have to do. That's how you calculate these limits and the value of the function. That's how you do all of this using a graph. So let's do another one, but this time pause the video. If you're kind of getting the hang of this and you think this makes sense to you, pause the video and try to do this next one on your own, and then just check your answers with what I get. But let's change this from negative 1 and let's do x equals 1. So let's get rid of the negative and do this for x equals 1. And again, I encourage you to go ahead and pause the video and try to do this on your own just to kind of see if you're getting the hang of this or not, and then check your answers with me after you do them. So let's go ahead and do this one. So let's do the limit as x approaches 1 from the right. So you start on here on the right side of the graph and you continue moving, and you move and it comes to right here. And right here you're at x equals 1 and you're at 2. So that means as you approach 1 from the right, you go to y equals 2. Well, let's make sure we know that's a 2. That's a 2. Okay, now let's do it from the left. So if you approach 1 from the left, so you come here, you jump up, and okay, now you're at x equals 1. And what y value are you at? You're at y equals 1 now. So that means this right here is equal to 1. Now again, this is another example where the limit from the right and the limit from the left are not the same. If these two are not the same, then that means the limit as x approaches 1 does not exist. Because again, they have to be the same for this to exist. Oh, good grief. Gosh. Okay, it does not exist. Now finally, let's figure out what is f of 1. So f of 1, where is the function defined at f is equal to 1? It's not defined here, it's an open circle. It's not defined here, it's also an open circle. The function is actually defined way down here at negative 2. So in this case, f of 1 is actually equal to negative 2. So that's all you have to do. That's how you calculate these. So again, I encourage you to continue practicing these on your own. There's tons of examples of these online. Just find a weird looking graph like this and go through and calculate the limits and figure out where the function's defined. And in the next video, we'll start calculating these algebraically, so we'll get away from using a graph to do this.